Okay, so this is going to be a fun uh, topic. Sometimes it could be fun, but what is very important about understanding the probability of at least one, or how to calculate the probability of what we call at least one, you really need to have a good understanding of complements. So, we're doing this by using the concept of complements, and that's very important that you understand what that is. And if you don't, you need to go back into my other video to understand what a complementary event is. Now, let's talk about at least one. What does at least one mean? At least one means one or more, right? I'm actually write all of this out because at least one means one or more. So let's say that I have 10 cookies. So so I have different cases from these 10 cookies. I can either eat 0 cookies, I can eat exactly 1 of the cookies, I can eat exactly 2 of the cookies, or exactly 3, or exactly 4, or exactly 5, or I could eat 6, or 7, or 8, or 9, or 10 cookies, right? This is the number that I eat. These are all the different scenarios, right? All the different outcomes. I can eat 0 cookies out of the 10 cookies, I can eat 1 of them, or 2. Now, let's say the cookies have different flavors. There's 10 different flavored cookies. So that means, let's say, for example, if I eat 1 of the cookies, I don't know which one it is. If I eat 2 of the cookies, I have a lot of different combinations of how I can eat those 2 cookies. I have a lot of different combinations as to how I can eat 3 cookies out of the 10. It could be a chocolate cookie, a peanut butter cookie, and a sugar cookie, or a sugar cookie and a snickerdoodle cookie and a white chocolate cookie, or, you know what I mean? I have a lot of different ways that I can go ahead and eat exactly 3 of the 10 cookies. So, but these are the total outcomes, right? Now, what does it mean? What does it mean? Let's do it in red. No, let's do it in yellow. What does it mean when I say that I want to eat? Let's just eat at least 1 cookie. What does it mean when I say I want to eat at least 1 cookie? That means I want to eat 1 or more cookies, right? I want to eat 1 or more cookies. So that's, all this, all the possible cases, 1 or more cookies. So I can eat 1 cookie, or 2 cookies, or 3 cookies, or 4 cookies, or exactly 5 cookies, or exactly 6 cookies, or exactly 7 cookies, blah, 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 right? I mean, that's a lot. What if I want the probability that I eat at least 1 cookie? I mean, that means that I want the probability of 1 cookie, or the probability of 2 cookies, or the probability of 3 cookies, or all the way to 10, right? When I do ORs, right, the OR case implies addition. So I'm doing probability of 1 plus the probability of 2 plus the probability of 3 plus the probability all the way to 10. Now that's a big calculation, okay? That's a big calculation, especially since I don't know the order in which I'm eating, let's say, those 3 cookies. I mean, just to calculate the probability of eating exactly 3 of the 10 cookies, that's a big deal in itself, let alone finding each of these different scenarios, because the order in which I eat those 3 cookies matters. So that's a pain. What is the complement of that? So in red, I'm going to talk about the complement. What's the complement of eating at least 1 cookie? Well, look at this. What's not in yellow? 0. 0 cookies is the complement of 1 or more, right? 1 or more is 1 to 10. Everything but that is the complement. Well, the only thing not included here is 0. So using my complementary rules to get the probability that I eat at least 1 cookie, remember the sum of all these probabilities has to be 1, right? If you think about sample space, right? And the sum of probabilities and in their complements. So what could I do? I could say, well, 1 minus the probability of 0 cookies eaten. and I'll get the same exact outcome. So this is a rule. This is a rule. Overall formula rule. If I want to calculate the probability of at least one of something, I can always make it easier for myself and say this is the same thing as 1 minus the probability of none of that scenario, right? If I want the probability that I eat at least one cookie, it's the same thing as doing 1 minus the probability that I eat no cookies. And I'm going to show you examples of, these situations in a second. So here's your quote-unquote formula. The probability of at least one is equal to 1 minus the probability of none, because at least one, that idea, and none, that idea, are complementary events. So they add up to 1. They're complementary events. Sorry that I kind of go diagonally. Well, let's see. Let's do an example of this, okay? I have 10 multiple choice questions on a test. So each question has 5 options, let's just say. So it's multiple choice. Each question has 5 options. So that means A, B, C, D, or E. So each multiple choice question has an A part, a B part, a C part to pick. Let's say that I'm randomly guessing on all of them. Randomly guessing on each question. Okay, this is my scenario. Let's just start with, before I go into more detail, what is the probability that I get one question correct? Just in general, just one question. Just one question. Forget about the 10. Let's just say one question. What's the probability that I randomly guess on one question and I get it correct? Well, if there are 5 total options, only one of the 5 are correct. So the probability that I randomly get one question correct is 1 out of 5. So therefore, the probability that I get one question incorrect is 4 out of 5. 4 out of the 5 questions are incorrect. These are complementary events. Now I'm going to go deeper. So this is just for one question, right? This is just for one question. Let's leave this here separate by itself for a second. What if I ask you, find the probability that out of the 10 questions, I get at least one question correct? Now, what does that mean? At least one means one or more. So if I want to calculate this, that means that I'm getting exactly one question correct, or exactly 2 questions correct, or exactly 3 questions correct, or 4, 5, 6, 7, 8, or exactly 10, right? All of this is included in the concept of at least one, right? One or more. Now, that is, again, like I said, a large type of calculation, cumbersome as we say. So what makes this an easier calculation? Well, what is the complement, right? What is the only thing not included here? What's the only thing not included in at least one? 0. So I'm going to say, well, instead of doing all of these probabilities, I'm going to say, well, I'm going to do 1 minus the probability that I got 0 correct. Okay? So now all I have to do is calculate this rather than all these 10 different probabilities. I only have to calculate one probability. Makes my life easier. But now I have to figure out what is the probability that in 10 questions, I randomly guess on all 10 that I get none of them correct. Well, on the first question, these are independent events, right? The probability of me getting one question correct is not going to affect the probability of me getting a second question correct, because I'm randomly guessing on all of them. So what is the probability that the first question is incorrect? Incorrect, right? 4/5. And how many questions are on this test? 10 total questions. So the probability, let me grab my calculator real quick. Where is it? So the probability that I randomly get, or on this test, I have 10 multiple choice questions. The probability that I randomly guess on every single one, and I go and I get them all wrong, right? I want 0 correct, is, let's do this, 4/5 to the 10th power. So 4 divided by 5 to the 10th power, right, is this part. And I want to subtract that from 1. 1 minus the last answer. So on top of the negative sign, you have A and S, second and negative. It's going to pull up my last answer. It's 89.3%. Okay, so this is approximately in percentage form. So we'll say 0.893 or 89.3% chance. Well, let's see if that makes sense. Now I'm claiming I go to this test and there's 10 multiple choice questions. And I'm saying that what's the probability that on the 10 questions I get at least 1 right? Well, do you imagine that if you go to a test and you guess on every question, there's 10 questions, you go and you guess on every question, do you think that you would get at least 1 right? I think that you would, right? You would expect to get at least 1 right. That doesn't mean you're going to pass it. You could get 1 right or 2 right or 3 right. That doesn't mean you're going to pass it. But I mean, at least 1 correct, I would imagine that's so. That's a high percentage, right? 89.3% chance that you go to this test and you have 10 questions and you guess on every single one and you get at least 1 right. That makes sense to me. Always make sure that your probability makes sense with your situation. Let's do another one from this book here. It has been reported that 20% of iPhones manufactured by this company for a product launch do not meet Apple's quality standards. An engineer needs at least 1 defective iPhone so she can try to identify the problems. If she randomly selects 15 phones from a very large batch, what is the probability that she will get at least 1 that is defective? So anytime I hear that, I mean, really, what I'm going to do is I'm just going to underline that. Okay, anytime you hear at least 1, you're going to use this concept that I'm talking about. So here, I'm going to underline that. At least 1. Anytime I see this, boom, at least 1, I'm using this concept, okay? So the probability, I'm going to go straight to the probability of at least 1 is equal to the probability, is equal to 1 minus the probability of none. I mean, you could use this formula. So the probability that you get at least 1 defective iPhone is equal to 1 minus the probability that you get no or none, but that's not proper English, defective iPhones from this company. Okay? Does that make sense? I mean, you can, like I said, go straight to this. The probability of at least 1 is always 1 minus the probability of none. I said that's kind of like a formula if you want to think of it. It's always the situation. So if you're going to use that as a formula, if you're asked to find the probability of at least 1, always write 1 minus the probability of none. And then, what is your situation? The probability of at least 1 defective iPhone is equal to 1 minus the probability of no defective iPhone. But you have 15 iPhones. Right? So I want the probability that at least 1 of these 15 iPhones is defective. That's my situation here. Well, I have to figure out for 1 phone before I could figure out 15. So let's look at just 1 phone. Okay, just 1 phone. What is the probability that that 1 phone is defective? Well, let's see. It has been reported that 20% of iPhones manufactured by Foxconn or whatever for a product launch did not meet Apple's quality standards. That means they're defective. So 20% of them are defective. So in general, if 1 is defective, the probability that it is defective is 20% or 0.2. For 1 phone, what is the probability that it is not defective? Well, if the probability that it is defective is 0.2, the probability that it is not defective is the complement, is 0.8. This is for 1 phone, just 1 phone, just 1 phone. Now I need to figure out one phone to figure out, 15. Well, let's look at now the probability of at least one defective phone, right, out of the 15. 1 minus the probability of none, or no defective phone out of the 15. So now I just have to figure this out. Well, what is the probability that one phone is not defective? The probability that one phone is not defective is 0.8. How many phones do I have? 15 of them. Don't forget, this is the multiplication rule here that applies, because I have more than one phone. If it were just one phone, it would just be 0.8. But I have more than one phone here that I'm talking about, at least one defective phone out of 15. Let's calculate that. Straight here. 1 minus, parentheses, 0.8 to the 15th power. Now, before I get this number, let's think about it. Do we expect it to be high? Do we expect this probability to be large or small? I mean, if you look, here we go. This is a large percentage. I mean, 0.96, let me write that down. This is approximately 0.965. So this is 96.5% chance. This is the situation. I go to, this engineer takes 15 iPhones from this company. And, we're saying that the probability that out of the 15, at least one of them is defective is 96.5%. That's a high probability that at least one of those 15 iPhones is defective. That means that this company sucks. Well, does that make sense? I think so. The probability that one of them is defective is 20%. That's pretty high. You go buy this phone, 20% chance that the phone that you buy is defective. It makes sense that out of 15, at least one of them would be defective, and that probability is high. 96.5% chance. Always make sure that the situation makes sense, or at least the probability, the numerical value that you get makes sense for the situation. Does it make sense that this would be so high?